Good afternoon. This is the last lecture in this series of 40 lectures on Six Sigma from IIT Kharagpur. I am Tapan Bagchi, and I'm going to lead you through some of the key points to ensure that you have success in your Six Sigma undertakings. As I show in the slide there, we'll be focusing on the operational excellence in each of the steps that Six Sigma project is supposed to move through. We have already reviewed that there are certain methodologies to be followed, certain goals and objectives to be followed, and these are going to be done in a systematic way. I'm going to lead through this in this presentation, and I'm going to actually point out some of the points which are pretty critical to keep in mind once you're moving through this particular process. Make sure the goals and objectives are clear to you. Make sure you understand the difference between sporadic problems and chronic problems. These are quality issues. Once in a while, some things may go wrong, but they may be also consistent chronic problems. These may come and go, but they are persistent. They come back one after the other again. Then you have to enumerate the different phases of the Six Sigma methodology, which we've done already, and we'll we'll take another look at that in this presentation again. Comprehensions are the basic tools, basic qualitative tools which are used for this. Moving on to the nature of problems, let's understand the difference between sporadic problems and chronic problems. Sporadic problems are adverse changes that are sudden and that can be restored in a short time. These do not require a long-term solution. Chronic problems, on the other hand, are problems which are intrinsic in the system, and they must be looked at from a long-term perspective. Without doing that, it's not very likely that you'll end up succeeding with your projects. We need to have a structured approach, and this I've emphasized many times. We've got to have a project-oriented approach. You set certain charters, you define the scope of the project, you look at the work breakdown structure, you deal with the sponsor of the project, which could be a process owner, for example, and you are the expert, presumably. You have the know-how, you probably have a black belt or something like that, and you are providing that expertise to be able to solve the problem. You've got to take this project-oriented approach. You projectize the whole mission, and you take a structured approach and follow through it as you move through the thing. Only then you can tackle the chronic problems. Certain generic project tasks are there. These are to be there in almost every project that is there, which is like, first of all, verify the project need and the mission of the project. Diagnose the causes. These are going to be part and parcel of doing the Six Sigma project. Provide a remedy, and of course deal with the resistance to change. This would be there because there are vested interests which are already there. People have been working in this area for a long time. They have certain practices that are ingrained to them, and you might change them. So there will be some resistance because things would change actually after the Six Sigma intervention. Things are going to change. Then after all, you've got to institutionalize these changes. You've got to make sure they become part and parcel of the institution. This again is required. So these are going to be certain generic project tasks that will be there. Then of course you got to remind people of the Six Sigma methodology, and more than anybody else you should remember what that Six Sigma methodology is. The mission of course is to try to reduce defects to the level of 3.4 parts per million, or 3.4 defects per million of parts. Any of those measures would be okay. That's symmetric. The Six Sigma methodology is related to projects that aim to improve existing processes through a very disciplined approach, which is the DMAC approach, and it's a data-driven approach, it's facts-based approach. We'll take a look at a couple of ways to achieve that. There is of course the DMAC process, which is applied when you are trying to improve an existing process. And if you're trying to develop a new process, then you'll be using a process that is very, very related to DMAC. This is called DMA-DV. In the last stage, you try to validate. You try to make sure that you verify and validate the new process to make sure it produces the results that you want. Just going over the DMAC process again, the 5 steps are pretty clear to you by this time. You define the problem, you measure the gap between what is expected and what you're getting. You analyze the causes for it, then you try to look for improvement. This will be done most of the time using those tools of quality improvement, or these could be done by design of experiments. Then of course, once you discover the new settings, the correct settings for the process, you'll be basically putting the process under control so that it sustains this excellence in performance throughout the time. Again, take a look at the DMAC process. There are 5 steps involved in this process. They define, measure, analyze, improve, and control. These are their specific tasks. These are their specific responsibilities. In fact, it turns out that the leading companies who ushered this new era, the Six Sigma era, for example, General Electric, as an example, they use the DMAIC process for quality improvement of existing processes and also for new processes. And they also use DMA/DV whenever they wanted to design a new product or a new process to produce something that is that would require the meeting of the stringent customer requirements. Those would have to be done under the Six Sigma logo. Let's take a look at the process itself, the Six Sigma DMAIC process itself. The very first step is define. You develop a charter. A charter is basically going to be something like your mission, but it's more specific. It sort of, clarifies why are you doing it. You make a business case for that project there. So every Six Sigma project must be made as a business case. You map the existing process, you come up with a flow chart, you define exactly what the stages are, and you try to identify where the problems are. And this you'd be doing probably partly by walking the process or by looking at literature. Again, you will end up with a process plan, or you may basically talk with people and so on and so forth, or get people's help to make sure the mapping is correct. Collect the voice of the customer. These are the people who are interested in the performance of the process. What are they expecting out of this process? And then, of course, make sure you define those CTQs, the critical to quality characteristics. And these are the requirements that the project must deliver, the process must deliver. Then, of course, you got the measure step, which includes measuring the CTQs. These are very, very important. Measure the CTQs, the critical quality requirements. Determine the process stability, also determine process capability. This it's measured by CPK. If you've forgotten about CPK, just look it up in a textbook or go to internet and read about CPK. This is a very, very important metric. Then, of course, you calculate the baseline sigma. So it could be that I'm just going to draw a little line here to show you what that is. There's the distribution of the full process, and I'm going to show it to you. Part green and part red. So there is some part that's going to be green, and then there are going to be these specification limits which are going to be coming here and here. And this part is the bad part. This part is the rejects, and also this part is the rejects. Now, in a process like this, it's only the part that is in the middle. This is the part that I can sell. And this part and this part, these must be scrapped. Now, as you very well know, in producing these parts, I spent the same amount of labor, same amount of energy, same amount of materials, and so on to producing those widgets there. Unfortunately, these do not meet my specification. My spec limits can be written very quickly as the upper spec limit and the lower spec limit. Now, there is a metric. There is a metric called CPK. CPK. This is process capability. This metric basically talks about the overall performance of this process, which is probably resulting from a lot of factors which are impacting the process. And CPK gives you a rough idea of what fraction of your production you can directly sell without doing any rework on it, or also the extent of scrap that you might be producing in your thing. So this is going to be your calculation of the process capability. That's going to be one of the steps here. Returning again, you got to calculate the baseline sigma, which basically says a process which is like this, the one that I have on the screen here. This process actually has a sigma level that is way below 3 sigma. Most likely this process is at 2 sigma level, or perhaps at 1.5 sigma level. And the process that you'd end up with after you've done your 6 sigma work is going to be a process that's going to be 6 sigma. And that's going to be wholly contained inside the spec limits. So this is the 6 sigma process, and the existing process, this one, might be probably 1.5 sigma. And this is bad news. This is bad. This is very bad. And this is good. This is very, very good. This is what we'd like to be able to do. So we'd like to start with a process which is like this. We'd like to move it up to this. And for this, I need that DMAIC step to be able to go from here to here. Couple of things we got to keep in mind. The first is that the average performance here, the average performance of the output of this must coincide with the target. That way, I'll have accuracy of the process. And the second thing that I must reduce this variability, and I make the process precise. So I need to have accuracy. That's one criteria. And also I need to have precision. in every process that I do. Unless I have accuracy and precision, my customers are not going to be happy. So this is something that I then refine into a problem statement. I refine this into a problem statement. I try to find out, is my accuracy out of control or is precision out of control? And then I have to apply the appropriate tools to be able to do it. Okay, moving on, I look at the analysis. I have this variation. I have this base variation. I have to do something to try to reduce that variation. Or I have performance that is off target. I have to restore that to the target. This also is something that I've got to understand and do it. So before I start my improvement, the first thing I must do is to try to get an assessment of current performance. This will identify the gap between what is expected by the customer and what your process is delivering. This gap is the one that actually hurts your business, because if the customer wants this and you're supplying this, there is no way this is going to be satisfying the customer there. So what I have to do is I have to narrow the gap. I have to really bring it right coinciding with the customer requirement. That's what I have to do. So in analyze, basically what we do is we try to analyze, we try to understand why this. And if you remember our tools, I'm going to be showing you that tool again. It's going to be the cause and effect diagram. And if I could quickly draw the diagram here, I have the effect here, and the effect is generally poor quality. And this is caused by numerous different factors. I'll have to somehow understand why, how and why these factors are affecting that quality there. The effect is actually poor quality. And poor quality gives you high variability. This is poor quality. Your specs are here, but you're producing stuff that is out of spec. And this is what I'd like to be able to avoid. So to be able to do that, I have to understand one thing. I have to understand how these different factors produce this effect. And for this, I've got to do root cause analysis. I have to identify the factors that might be doing this. So this is the part that is called your analysis. Then moving on, we've got the improve stage. And that is the part actually where most of the real tough work in Six Sigma is done. This is the place where you try to come up with ideas, you come up with methodologies, and these methods basically would engage techniques such as design of experiments, perhaps regression, perhaps optimization, and so on. And basically, these are the steps that will make sure that the process improves. The problems that you identified in your root cause analysis, those are rectified, and eventually the process ends up with a 6 sigma quality, or at least 3 or 4 or 5 sigma, if you're staying at 1 sigma at the base stage. So in the improved stage, I'll have to select the solution. I'll have to design the solution. I'll have to pilot the solution. I have to make sure I demonstrate that on the shop floor, and then I have to implement the solution. These things will have to be done right at the improvement stage. Then, of course, once I've got my improved state of affairs in hand, I've got a good record of it. I've got to make sure that that new process or the new method gets institutionalized. And then it stays there. For this, I need to institutionalize, of course. That's something institutionalized means it becomes part and parcel of the company, part and parcel of the shop floor. I control the deployment. I make sure that the process variables, different process factors, they now maintain the level at which they are set when they are running at the optimum condition. I've got to be able to do that. I've got to quantify the returns from this. So, for example, in this case, as you see in the diagram there, I have really, in this diagram that I have on the thing there, this money is not with me. This money is also not with me. These monies are not there. The only money that I have that I can call the results of my business is this part. So this is where probably there will be some profit. Probably the sale of these goods, probably it is just recovering my cost. And because I have this loss, and this loss, these are of course your cost of poor quality losses. I've got to remove them. Now, if I've done a 6 sigma project so that I've removed them, I don't have this and also I don't have this, then I have to put down the new financial results. New financial results. And this might require audit. So you do an audit. You do an audit to find out, has this actually happened? Do the audit to confirm that the results have actually been achieved and you're saving money or you're making money because of additional profit. That is something that will have to be done. present the final project results to the people who are the stakeholders, and of course you close down the project, you release the resources, and perhaps there is another 6-figure project waiting for you to take over. Let's look at some of the details again. The DMAC strategy, it's a strategy. It's a way that guides your long-term actions. So therefore it's a strategy. And it again agrees with the mission of the company. The mission of the company is to be able to outcompete the competitors. It is to be able to, grab the business from other people, perhaps by providing better service and better quality products. That's your mission. That's what leads to strategy. Strategy actually spells out the steps, and one of the key steps in improving quality is do it the DMAC way. Do your improvements, do your quality improvement projects the DMAC way. Now, what am I doing in define? Again, to remind you, I'm defining the problem. I'm selecting a cross-functional team. The team must have expertise in different areas. And also define the charter, team charter. What is it that the team is after? Because from the charter, I'll define the scope of the project. Then, of course, under measurement, I'll select the CTQ characteristics. CTQ are quality, those quality characteristics that are critical to quality. They're critical to customer satisfaction. Those I'll have to select. Define performance standards, and these generally come from customer expectations. Then, of course, you validate the measurement system. I cannot tell you how important this third point is under measurement. Many times what happens when we measure quality, our measurement system is not good enough to be able to tell between good and bad. It can be as bad as that. And this is something that has to be checked before you get into a 6-figure project. So please make sure you do gauge R&R studies. If there are some measurements involved, you do gauge R&R studies. And you take a good look at the training level at which people are performing their quality control tasks. Quality control inspectors, are they really trained to use those equipment, those instruments, and so on and so forth? Do they produce good results? What about your overall gauge R&R variability? Is that sufficiently small? When you look at process variability, suppose you are trying to measure, for example, you're trying to measure this old picture that I had there. You're trying to measure quality on this, and suppose your measurement itself is widely variable. Let me just put down a measurement variability there. Let's see your measurement variability is this wide, which means that if I measure the same object, I can get a reading here, or I can get a reading here, I can get a reading here, I can get a reading here, and so on. With this sort of high variability, I can't really say if I'm meeting specs or if I'm not meeting specs. I cannot do that with a measurement system that is as bad as this one. So what I have to do is I have to make sure I convert this, I refine this into a measurement system that itself has very little variation. This is going to be a desirable feature of a quality arrangement system, quality improvement system. So this is also something that you must really ensure before you go into your measure step in the DMAC process. Then, of course, comes analysis. Analysis basically looks at the root causes. It looks at establishing process capabilities, so you really know how good or bad your existing process is. I mentioned CPK. That's like one of the key measures of how good or bad your process is. Then you define performance objectives. What targets do you want to meet? What kind of capabilities do you want to deliver? What kind of quality do you want to deliver? What level of customer satisfaction do you wish to achieve? What are your competitors? What are they offering to you? This is something that you got to be able to do. Identify the sources of variation. This also will be done by you, and this will be done using that cause and effect diagram and doing your brainstorming. This is very, very important, because in order to do your improvement, you need to play with these parameters. And these parameters must be there, 3, 4, 5, 6, any of them. They may be there. You may have to go after each one of them. You have to do the designed experiments to be able to see you've identified factors. You know exactly what they need to be reset rather, to be able to deliver the optimum performance. This is something that you'll have to do. Then, of course, you got the improve stage, which is when you screen the potential causes. You don't work with 35 causes. You work with 4 or 5 or 6, and these seem to be the most promising ones, and there are ways to do it. One is, of course, the orthogonal array experiment, which is done with a large number of factors, but a very sketchy type of matrix type of system, where you basically try to screen out factors that really do not have much of an impact on quality, and the ones that you retain are the ones that have got a lot of impact on quality. That is something that is done at the screening level. Then, of course, you'll discover variable relationships. You must have this cause and effect relationship. So I had that effect here in this diagram. Remember this diagram that I have there. There is some quality problem there. Quality is missing there. I have to link that to these factors. I have to link that to these factors. Today that is unknown. Through your investigation, you will actually find out, is quality affected by factor C? Is it affected by factor D? Or is it not affected by B or A? Then I need not worry about A and B. I need to then work with C and D, and I need to find the optimum settings for C and D in order for this Q to go exactly where it should be, which is like to take this to tau. I really have to drive this Q to tau, the target. The target is the point where the customer is happiest. That's what I have to do. I would like to be able to do, and that will be done by controlling these two factors. These are the factors which are the culprits. So I have to adjust this, I have to adjust this. Once I have discovered the best settings for C and D, I have to make sure that the plant uses those settings. And for that, I've got to have this control step. And the control step basically says, again, please validate your measurement system. Make sure measurement errors do not clutter up things. And then, of course, what I'll be doing is I'll be determining process capability. This will be under the new conditions. And you implement process control. You've got to make sure that the right values for D, which could be D star, and the right value of C, which could be C star. These are the ones that the plant uses routinely. And this is a function that you have to do as someone who's in charge of sustained results from that Six Sigma project there. Again, under DMAC, but basically what you're doing is, whenever you're doing DMAC, at each step you're asking some critical questions. Let's recall those questions again. Define says what is important. What is important to me? What is important to the business? What is important to customers, after all? Measure says, how are we doing? Something is important, but how are we doing? What is our performance like? This is where process capability would come handy. Analyze, try to find out what is wrong. And this would require use of the cause and effect diagram, use of the fishbone chart, and so on and so forth, to try to make sure you at least get the tentative list of factors that you'll be playing with. Then, of course, fix what is wrong, which means discover the relationship between the input factors and the output, which is your quality, which is the quality that you desire. Work out the relationship. If you understand this relationship very well, you'll be able to set the input factors, like I set here C and D. I set them at D star and C star. Those would be the right settings to deliver my quality at tau. This would be my goal. So I fix what is wrong in the improved stage. And in the control stage, I want to make sure those C star and D star values, they are sustained in routine production in the plant. And that will be done to ensure gains are maintained to guarantee performance so that the customer stays happy. Let's look into the define step a little bit. Clearly identify the problem. This is going to be very, very helpful once you're in this define stage then. Utilize numerical information and make sure you quantify things to the extent it is possible. Focus on processes that create the problem and not the outcome. Once you got the idea of the outcome, then go into the problem itself. Get deeper into the problem. So how do I do it with excellence? How do I do this define step with some excellence? Let's try to take a look at it. Identify the internal and external customers because they have the requirements. Determine what our customers want. Identify the suppliers. Determine what is needed from our suppliers. Identify problems that may be there from suppliers themselves, or the way we handle our material once it gets in, or the way it is mounted on the machine, and so on and so forth. So those things would be there. Identify the process conditions that contribute to problems. This is like something, perhaps when humidity is high, temperature is high, speed is too high, or something like that, I have problems. Or when conditions are dusty, perhaps I have problems. Or when the worker is tired, I have problems. Or whatever it is. Or when the supplier is switched from A to B, I have problems, and so on and so forth. So this is something that I'll have to probably find out. Identify improvement opportunities, and this can be done once you have a general knowledge of the process and you're interacting with the people who are day in and day out with the process. You'll be able to identify a lot of improvement opportunities which will be there. These still stay in your mind tentatively as hypotheses. These are guesses. You'll have to verify that. As you go through the Six Sigma process, you'll have to verify these improvement ideas. Scope the improvement project. That means you try to get some idea of how much improvement you can possibly achieve, which can be done by either looking at a benchmark or by doing some trial and error type of thing. With that, you'll get an idea of what sort of leeway is there, what sort of room is there for you to improve. Select the right players. These are the players which will be working on your team. These are your team members for the Six Sigma project. And of course, then you set some stretch goals and objectives. All this will have to be done at the define stage. If you're doing it right, you would really not have much of a problem. Measure the next step. The first thing is benchmark your process. You make sure you understand the capability of your process. You focus on CTQs. These are quality characteristics that are critical to the customer. And how do you do this? How do you do these 3 steps really, really well? Review the current process. This is something that you'll have to do by doing some flow charting and so on. Identify the key inputs and output. This also is something that you'll have to do without too much delay. Develop baseline and the entitlement matrix. This is like for performance and cost. There are certain entitlement matrix. These basically say that unless I have this baseline achieved or reached, I'll really not have business. Collect or organize data. This also you'll be doing under measurement. And you could do, for example, one example is you could plot a histogram of the current performance. That is something that would give you a lot of information if you produce a histogram of the output of the process. Collect or organize data. So that we do there. Evaluate the performance of the process. Look at defects. Number 1, count of defects or fraction of defects or percent of defects that you produce routinely as is. And also take a look at your cycle time, because Six Sigma not only looks at reduction of defects, it also looks at reduction of losses. And one big loss could be production loss, because your times taken are far longer than they need to be. And of course, you assess the amount of variation. This could be done. Variation could be in the process, or it could be in the measurement system. Both of these have to be ascertained. Unless you've done this, of course, you stay confused forever. You would not really know whether your data is good enough to go into analysis, or is it going to be something that's already at a high level, a pretty accurate level and precise level, to really not give you much trouble at all. This is something that I will just adjust the mic for a second. Yes, it is back, and it's on my collar. No problem there. Okay, now the analysis would be on the current process, and analysis also will try to give you an idea of, compare your performance to what the competition is doing. That will give an idea of the gap that is there. You do these things very well if you follow these steps which I have listed out here. Identify issues that occur at each step of the process. Issues means these are the problems that might occur. People may talk about them. What are those issues? Assess customer impact of problems. Try to find out and get some idea of, what if I ship out something that is defective? What is the impact of that on the customer? And that could be just the next stage of production. The customer did not be the guy who's standing outside with a wallet in his hand. It could also be someone who's just the next stage of production. It could be the next person in the production line, the next workstation, for example. What is the impact? What is the impact of my poor quality on them? That is also something that you'd like to be able to do. Prioritize most of the critical input. You make sure you really start with the big ones that have a lot of impact versus those that probably do not have as much of an impact. Assess the effect of the output on performance. This is also something that we'll have to get some idea of. Determine root causes, and for this I'll be using the cause and effect diagram. Generate solutions. These might come once I've got the cause and effect diagram ready there. A lot of ideas will start generating, producing, because after analysis I'll be moving into improvement. And select the most likely solution. I enter improvement, which is like implement changes. This is like after I discover the optimum settings. I have to be creative in this ideas to find new ways for doing things. And how do I do these things properly? Develop action items. What are the things on which I'll be working? Prioritize the improvements. Test the solutions. This would be done, most likely this would be done using some statistical methods. Determine the best combination of inputs, and this would be done again by design of experiments and controls. Refine the solutions, and that could be done again by design of experiments, DOE. Document the solution, implement the solution. I will tell you this, that by far the training that the black belt people receive, those are most effective and useful at this stage, the stage of improvement, because this is where you'll be using a fair amount of statistical methods to try to make sure that you make an impact on the process. The process may be pretty complex, and just by, if it were to be solved by common sense, that it would have been solved long time back. But because it can't be done that way, people have to resort to methods like such as design of experiments. The last part, of course, is locking in the success that you have, and you've demonstrated some good levels of the process variable for the process variables, and you got to implement measures at this point to make sure those variables stay within the new operating limits. How do I do them well? Measure progress to make sure that if you bring in those changes, they actually produce some outcomes. Capture and quantify benefits of the process improvements, document the project. This will provide the motivation for doing more Six Sigma projects. Communicate to the wider organization what all things you've learned, because so that other people can learn from this, recognize the team's effort. You got to make sure you provide incentives for those people, those who worked hard to make sure the success was there. Monitor and manage the hold gains, whatever you've gained, make sure you monitor them. When the production starts on a routine basis, when that thing is resumed, you got to make sure you monitor that the output of the process there, and you also got to make sure it holds there. And of course, you try to adjust for continuous improvement. This is what we borrow from total quality management. So there is some little TQM that's moving in here. As you can see from this picture that I have here, we've come a long way. We started with inspection. Inspection was the first step when I checked quality only by inspecting the item. That's all I did. All I could do at this stage was to sort items between good and bad. That's all. Then people realized that they had to control the input, which is like they have to control the process that produced those products. And they got into this idea of process control, which is used as a feedback loop. Data analyzed statistically become the feedback, and that's what is used to try to keep the process in control. And we use control charts for this. Design of experiments was the next step in this march toward perfection. And that actually basically is a tool by which you can identify, it's a procedure by which you identify which factors cause the maximum impact on the output, on that quality there. Toguchi methods are ways to produce great designs and robust designs and keep production on target. Then of course you've got quality management system. These are required to make sure you have an overall management system to guide it all. Because if you have this overall management system, only then the good processes will stay in place. This is something that's part and parcel of this. You remember we did ISO 9000 some years back, about 20 years back we did ISO 9000. The goal really was to put our house in order. That was the mission in ISO 9000. Then of course many other people, they felt that ISO 9000 was not sufficient. And the automotive people, they came along with a system called QS 9000, which brought in a few statistical methods, also including SPC, also as part of the routine. So not only your house would be in order, also your processes would be in control. Then of course later on, total quality management came along, and that has those 5 steps, if you remember. Top management's direct involvement, strong customer orientation, systematic methods used for problem solving, everyone is involved, and the theme is continuous improvement. These are the themes that TQM pushes. Unfortunately, the only thing that is missing in making sure companies go with this TQM approach is that the incentives for doing TQM are not very clear. In fact, at no place in TQM, even if you quantify the cost of quality, cost of poor quality, try to quantify as part and parcel of a TQM program, you really do not work out something like that the Six Sigma does. Six Sigma basically launches every quality improvement project by first identifying the incentive for doing that project. And it works out, it projects an ROI for doing that project. And then after the project is completed, it verifies that yes, the ROIs have been achieved. So there is a direct dollar incentive for management to support TQM, Six Sigma projects, which was missing in TQM. TQM basically told you a lot of things that you should do, and you had to take it on faith that these would be good for the company. But again, managers, because they could not see dollars in it directly, they did not see the dollar benefits. They were indirect, but the dollar benefits were not visible under TQM programs. Six Sigma took over, and Six Sigma basically made sure that every quality improvement that you start, the very starting point will be quantification of the incentives for doing those projects. Six Sigma debug model is very systematic. You identify the opportunities, you do certain things there, you form a team and scope the project. So you clarify there who will work on what kind of expertise you're going to bring in, and what will be included in the project, what will not be included in the project. You'll be analyzing project by doing competitive analysis and number of other things, including various tools which are there, summarizing data and so on and so forth to try to understand you get a good idea of what the process is doing now. You define the desired outcome. This is also part and parcel of doing good DMAC. Then of course you go after root causes. You try to work with the cause and effect diagram and a number of other ideas, such as brainstorming and flow charting and so on and so forth, to try to understand, you pinpoint the root causes. Then of course at this point you prioritize the plan and you try to do design of experiments, and you discover what we call the factor effects. The factor effects are done right here, if you might remember, and you can actually go back and revise and view the lectures on design of experiments one more time. That will tell you which factors are important, which factors are not important, and the factors that are important in delivering quality, what should be their optimum settings. These are discovered by doing DOE, design of experiments. Then of course you will refine and implement the solutions, and you'll put down some monitoring device such as control charts and so on, so that you basically keep an eye on how the process is doing after you've gone through it all. And of course, hopefully, you'll be making more money, you'll be getting awards and so on and so forth. So it's a pretty systematic process. Six Sigma DMAIC turns out to be a very systematic process. And as far as DMAIC, the impact of DMAIC is concerned, you look at cycle times, look at defects. This is the low end of cycle time. That's like small cycle times and low defects. This is the high end of it. If you start here and if you keep doing Six Sigma projects, your march is going to be like this. And you could actually reach the level eventually. If you put enough effort into it, that will be best in class, perhaps best in the world. Six Sigma, therefore, is really, really different. It's very different from the traditional way of trying to manage quality, try to monitor quality, and try to improve quality. It begins with a problem and a process definition. It uses measurements. It uses a systematic methodology which has been proven out. It implements that methodology to make sure actions are there to try to improve this. It incorporates continuous improvement, and also it very much looks forward to control. What are some of the qualitative tools used in Six Sigma? Brainstorming and affinity diagram, these are one. Pareto analysis, which tells you which things are important, which things are probably not so important. So if you've got various types of customer complaints, which are the ones that are more frequent, first attack those. Then of course you got the cause and effect diagram. That's a very, very important tool. And I just can't tell you how much I love this little tool here, which again I'm putting on this diagram here on this paper. This is the cause and effect diagram, and it basically helps me to brainstorm, look at a quality problem and try to speculate about what different causes could have caused this. Then I can begin my march toward improvement. Then of course I've got process mapping, which basically talks about what are the different steps through which the process moves. The quantitative tools are many, and I've listed out a few there. Statistical testing, which is a test of hypothesis, when you're comparing the output of a machine before and after reconditioning, for example, or before and after a technology change or a tool change, for example. You'd like to be able to compare two outputs. And in fact, it could go like this. If I show it on a picture to you, let's say the existing process was like this. This is some quality characteristic, and the old process was like this. And I improved the process, and I have a new process now which is like this. Now what I'm interested in knowing, there is some variation here, there is some variation here. But what I'm interested in moving is this movement real? Is this change real? And this can be answered by, for example, the t-test in statistics. So it's a statistical test, or of course you could also do the f-test. T-test is used when you're trying to compare, for example, machine output. This is machine, the old machine, and this is machine after the improvement has been made. So this is machine improved. And your mission is going to be, hopefully this produced an impact. Is that real? That I can find by doing the t-test. And of course, if I've got a system that is affected by multiple factors, for example, if I had the old process with a little cause and effect diagram and many factors impacting quality, I can actually use this technique called DOE, design of experiments. And DOE uses the f-test. So there are certain statistical tools that are available to you to answer virtually any problem that might be there in regard to data or in regard to the output that comes out of a machine, for example. So those methods are there. Statistical testing is there, design of experiments is there, and of course control charts. I'm going to give you an example there. Process capability, this basically tells you what fraction of your output is acceptable to customers. And indeed, if quite, if you really are running quite a tight process. Then of course you've got reliability analysis. These are the different statistical tools that are quantitative tools within Six Sigma. Tools and templates, and I'm giving you a slide here which actually lists many different tools, and it shows you the stages of DMAIC where those tools are used. So I have affinity diagram, brainstorming, and I've got force field analysis and 4UP. These are the ones which are used at the define stage. Let's go right to improvement. Then of course I've got implementation plan, I've got brainstorming, I've got controls, I've got then I've got design of experiments, I've got decision matrix, I've got the 4UP. These are the methods which are utilized. These are the tools which are utilized in the improvement stage. Look at controls. I've got the business impact, I've got control and reaction plan, I've got the control chart. These are going to be there. And of course, there are going to be some of the methods also which are to be utilized here. So basically, it's not true that you use all the tools all the time. That is not true. There's an appropriateness for each tool to be used at a certain stage, and that is shown here. If you look at the DMAIC process, there are some more tools there. For example, the Ishikawa diagram, measurement system analysis, motivating, multi-voting, this is also there. Then of course, Pareto chart is there, process capability there. Notice a lot of these really are focusing on analysis. And as far as improvement is concerned, I've got CPK, process capability there. I've got process maps. These are going to be utilized in improvement, and controls will utilize. For example, the Six Sigma calculator, that would be there, and the storyboard. These are various different tools which are utilized at the stages which are shown here. Now the team charter, how do you actually identify the charter? I've given an example. Basically, when you ask the question, what is the team's charter? It will identify what is going to be the focus of the thing, what are going to be the boundaries of the project. That is like what will the project include, what will it not include, what are going to be the expected outcomes, and why this is important, what is really driving the motivation for it, and who are the key players who will be providing the basically the expertise for it. And here's a worksheet. You can read this and you'll get a pretty decent idea of how does one go about defining the team charter. Then walking through the process, the thought process itself when you're doing define is, what is the problem? Do we have any data or information on the problem? Just think of this. Think of being at the define stage and you're asking these questions. What is the problem? Do you have any data or information to be able to say, shed some light on the process? What processes are being considered? This also has to pin down. And what are the key questions that need to be answered? These are queries that you might like to answer. And here's a way to lead your path in the define process. You could start with the top level process. You'll have a starting point, an end point, and you'll have some major points in the process map. There's a top level process map. Then of course you'll have to measure things. So what is the output? What is the output volume of the process? What are the opportunities for error? Because I've got to come up with a DPMO. So I've got to know so many parts, so many defective parts per million opportunities. So I've got to have an idea of that. How many defects are being produced and what is the performance level of the process under the DPMO measure. And that's shown in the calculation which I'm showing on the right hand side of the block. Measurement, of course, you can use descriptive statistics very well. Is the data normally distributed? That I can find out by drawing the histogram for it. What are the confidence intervals? And that also can be found out. Once I've got the data there, I can find out with 90% confidence what can I say about the output coming out with 90% confidence. And can I use the same data for further analysis? These would be the various descriptive uses of the data. When I'm doing control, I will be using something like, I'll be looking out for trends in the process. I'll be looking for variations in the process. Is the process stable? Is it capable? And those can be found out by looking at the control chart of the process. Measure, of course, something that is very important is I've got to map the process completely. So in fact, I'll probably list out all the steps in the process, and that would look like this. Eventually, I'll end up with a map like this. That basically starts with the inputs, goes through the process steps, then it comes up with an output. And this process starts right at the beginning, and it winds itself throughout the business process and the physical process of the system itself. And it goes on, and so on and so forth. Measurement system would really look for what goes wrong at each step of the process. This is very important. But these are some of the things that you might have logbooks to look into, for you to be able to look into what are the majority of the problems. This could be done by Pareto analysis, what functional areas are most affected? And these are the ones that will probably have a lot of work that is piling up because quality is not moving very well. The cause and effect matrix, and this of course leads to our cause and effect diagram, this Ishikawa diagram. This is a very, very important tool. This actually indicates what process inputs lead to the problem. What are the categories of these roots? Man, machine, materials and methods and so on and so forth. That is something that could be done. And that can be done by looking at a diagram like this. And you can put down the methods, first put these captions around, then start filling in factors in the environment, factors in the methods, factor in the materials and so on. And you end up with capturing most of the things. This is like an example. This is like an example of a real cause and effect diagram that was generated by someone who was trying to analyze a particular problem. Analysis of data, output data by Pareto, which root causes really should we focus on first? Because then I look at the kind of defect that I'm looking at, and look at the one that is most critical. That's the one that's most frequent. This can be had very easily once I do my analysis using the Pareto chart. Then of course there's a process called FMEA. FMEA is a way to try to predict how a process or a product may fail. FMEA is a very routine procedure. We spent one lecture on FMEA, so go back and review the FMEA process one more time. Two aspects are looked at. If there is a failure that is likely, how likely it is going to be, what is going to be the consequence, what is going to be the impact of it, and what is going to be the likely impact on the customer of that thing. This is done by the FMEA worksheet. And once you've done that, you identify RPN, the highest RPN, that is the risk priority number. And that basically tells you this is the aspect of your design or the process that needs some action right away, as quickly as you can. And there are other methods also, where again you look at the sources of different variabilities. This could be done by collecting data, and you try to find out there are several sources that could lead to variation. And where would these come from? That can be done by doing what we call looking at the components of variation and looking at the key troublemakers. That can be done. Improvement would be one way to do that would be to take a look at the mean square error. This is like very, very important. And this is done with the measurement system. You try to take a look at the measurement system itself, and there are certain procedures available. I have given you the method for gauge R&R studies, and those are the methods that are utilized to try to make sure your measurement system has the capability to be able to basically to enable you to conduct first of all data collection, then measurement of the performance of the process as it is, then again at DOE or even after DOE once you're doing controls, you've got to collect some data, you've got to be able to analyze those data. If the data are of poor quality, then of course everything goes out of the window. So you've got to make sure your measurement system is in good place. So do have gauge R&R as one of the key steps in your Six Sigma study. Improvement comes along by this dear friend of ours called design of experiments, which is a very disciplined approach in which you vary multiple factors. You vary multiple factors together, and you look at the output. You look at the output of the factors. When you're manipulating these factors, you look at the output. And you analyze the output in a way when you can find these factor effects. You might remember some of the curves I showed you were different factors that led to different extents of impact. We did that Nissan logo falling off problem. There again, we plotted the impact of the various things like glue, sticking strength and so on and so forth, the thickness of the styrofoam and so on and so forth. Those things we looked at. The idea was conduct your DOE and make sure identify the factors that are causing most of the problems in the output. Then we locate also the optimum setting for those factors. So in our case, it turned out glue really did not matter that much, but the adhesion area was a very important one as far as Nissan's logo mounting problem was concerned. Improvement actions, of course, will follow through DOE because you've identified the different factors that might have caused the problem. You should quantify some of the things. What are the expected benefits? What are the deliverables? What is the implementation schedule? Once you've got the new plan in place, you've got to think of controlling things. Do the key outputs. Now, this is like after the results. Do the key outputs meet performance standards? What are the most likely causes for an output going out of standard? What actions are to be taken? Who is going to be responsible? So, for example, when you put the control actions in place, when you go put control charts in place, you got to make sure the control actions restore the process in its statistically controlled stage. So control reaction plan is part and parcel of it. You've got to make sure whenever you got a point out of control, you bring out the reaction plan and it takes some action there. Control action will also going to be looking at the business impact of your process there. So there are going to be some measures there that might include cost counts, cash flows, growth, impact on profits, and so on and so forth. Some final thoughts about Six Sigma tools. These are some of the things that really one has to keep in mind. We got to make sure we select the tools based on what you want to do. We also use the tools in a good way to make it, because using the tools is a good way to share knowledge among team members. Sequence of tools, use documents. If sequence of tool use documents the team's thought process. So if you're using certain tools, basically the sequence in which you are using, you're not using DOE just to begin with. You're doing a lot of data collection and so on and so forth. So using simpler tools, then you get to the cause and effect diagram, and then you go to DOE. So if you show this use of these different tools, that actually becomes a great way to find out how the team progressed into this. So if you make a Six Sigma presentation, if you start out with your DOE, people would have many questions. They would like to know, how did you really think of DOE to be the best way? So this is something you got to keep in mind. Never use a tool that is more complex than the problem that you're trying to solve. So DOE is not obviously the answer when you can fix it in many different ways. And so do not become slave to your tools. And of course, we got to make sure we have a method to design products also to lead to the Six Sigma process. And there again, we will be using the define method there. The last step, define, measure, analyze, design. This is where it depart from the, because in place of improvement, we've got design here and validate. So we had improvement and control. Now under design, designing products for Six Sigma, we've got design and validation. These are the steps that walk in. And what is a design? What is design for Six Sigma? What is the DFS system? It's a customer-driven process. It predicts design quality upfront before you get into this. It looks at CTQs. It utilizes cross-functional capabilities. It drives quality measurement and predictability hand in hand. It utilizes process capability information to make sure the design decisions are right. You're using the right process for the purpose, and it monitors process variations. This is something that is done by design of excellence. And basically, if you're introducing a new product, you should be moving this way, which is like you start with a market research. And that might include QFD, it might include the Kano analysis. That will lead to requirements, that will lead to the design. Once you design the product, it will lead to some decisions about the process. So you'll move slowly into production. Then of course you'll move into logistics to make sure the products get out to the customer's location. Then of course you'll have to worry about distribution. And of course, after you've delivered, there's going to be some service and sales support. These are going to be there. And please keep in mind, Six Sigma is not focused on manufacturing only. It can also help you in a big way as far as services are concerned. And if you look at this total span of things, if you look at the total span of activities, you can take a look at any aspect of it and you can approach it using DMAC, because there are many internal customers throughout, and the internal customers should be treated with the same respect as people who come back and pay you money. And talking of money, let's make sure that we at some point in time will remember that after all we are doing all these things to be able to eventually deliver some money to people. So you got to make sure you show them the real money there, and that's what you're after. So your team should remember that in the end you got to produce this extra money beyond what you produce under routine business. Hope you enjoyed it. Thank you very much, and good luck with Six Sigma. Thank you.